Hey everyone, welcome back to my channel EduVibe. Today we will start with the another topic of matter and the chemical bonding, which is the molecular polarity. So this is a topic is more like a theory part. We will learn about what are the polar and what are the non-polar bonds. So this is grade day 11th chemistry, and we are doing the molecular polarity today. So let's start with the first, that what is polar and what is non-polar bonds. So the nonpolar covalent bond is when there is a symmetrical electron charge distribution among the atoms. So if there is a symmetrical electron transfer, and more if we want to know the non-polar particles which are soluble in water. If you want, so they are also which are soluble in water. Forms when the atoms have a electronegativity difference of zero point 0.4 or less. And this is also the electronegativity concept more when the electronegativity is less than or equal to zero point 0.4. So this is the non-polar covalent bond, any if we have a bond. So then the polar covalent bond is when the electrons spend more time closer to the one atomic nucleus than the other, resulting in a partial positive and the partial negative end. So when the partial negative positive end we have in some terms, so this is called the polar covalent bond, and this is insoluble in water. I said sorry, this is insoluble in water. This is soluble in water. So non-polar covalents are insoluble in water, polar covalent bonds are soluble in water. And the overall charge of molecules is still zero in the non-polar. In the polar, there is still zero. Forms where the atom's electronegativity difference greater than zero point 0.4 but the less than or equal to the 1.7, which means electronegativity is greater than equal to 1.7 and greater than 0.4. So at that range, we have the polar covalent bonds. And the greater the electronegativity difference, the more the polar is the bond. So if we have a like 1.6, 1.7 electronegativity, so it means that we have a more polar bond in there. We have an example for this. We have two of the elements, phosphorus and actinium. So phosphorus is noted by P, actinium is noted by AT. If you see a periodic table in your data booklet, you will see that P has electronegativity of 2.2 and the string has the of 2.22. So this means when we difference them, we get the zero. So when we get the zero of the any electronegativity, so this means this is not polar. So this is either neither the polar or the non-polar. So this is remains the not polar. Okay, and if we have carbon and nitrogen, so carbon and the nitrogen, carbon has electronegativity of 2.6, nitrogen has 3.0. So when we find this, so 3.0 minus 2.6, we get 0.4. So means the 0.4 means this is not polar. If we get the greater than 0.4, so we'll see that this is a polar bond. So that's how you can find the electronegativity, but this is not like the thing. You just know this theory part of this, that what are polar and what are not polar molecules. And in the in previous lesson we do Vesper theory. We call it the Vesper theory, and the Vesper class, which we call the molecular class, like linear we do band, triangular panel, we do tetrahedral, we do pyramidal and all. These are also valid for the polarity concept. So if we want to find any the molecular polarity of anything, firstly when we get that any element, that any molecule compound, we have to make their bond polarity means we have to make their stereochemical formula for this, stereochemical structure for this. If we get this type of structure like this, we have same element, we have same satellite elements, so this means this is non-polar. If we get different, like we get one of hydrogen, other of oxygen, center we have carbon, so this type of thing if we get, so this means this is a polar. So if we take a different of the elements, a different satellite element atoms, so this is polar. If we get the same, so this is non-polar. In the band 2, Band is the exception for this. Band and the triangular pyramidal both are the exceptions. They are the same satellite elements, but they still has the polarity. This one also band has same of them. This has the polar, and the rest of all has that same property. If they have same, like this has the same of the element triangular, so this is non-polar. If you have a different one of the difference, so this is polar in triangular panel. If we have all the difference in pyramidal, also non-polar. One difference, this is polar. So you have to learn, you have to kind of know this concept that what are non-polar and what are polar. In the band and triangular parameters, we have exceptions of this. So this is all the table we have to learn for to do red polarity questions. So you get some theory questions from this, and we will do the next topic when you have more clarity of this topic and how these bonds are done, because we are doing the intermolecular forces in this, and we will learn more about these. So this is all for this lesson. This is such a short lesson. So in the next lesson we will do the last topic of this unit, which is intermolecular forces. So learning based every EduVibe, learn smarter but not harder. Please like, share and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, stay creative with EduVibe.